Hello, my name is Nathan, and I want to talk to you today about the brain. More specifically, I want to talk to you about the role the brain plays in maintaining body weight and how metabolic diseases, like obesity, may be related to changes in how our brain works. Obesity is a leading factor in worldwide mortality and a major driver of chronic diseases like cardiovascular disease and type 2 diabetes. To give you an idea of the scope of the problem, obesity costs the Australian healthcare system somewhere in the range of $8 billion per year. And that is a sum that can be largely attributed to a serious lack of available treatments. See, while changes in diet and exercise play an important role in bringing body weight under control, they are often insufficient to overcome the significant and long-lasting physiological changes that alter the way an obese person regulates energy balance. But what do I mean by energy balance? Well, energy balance in the body is the difference between how much we take in and how much we burn off. When we eat, we are increasing energy intake, and when we exercise, we are increasing energy expenditure. Under normal conditions, the mechanisms responsible for maintaining energy balance try to keep body weight around a set point. In obesity, however, these mechanisms are disrupted and the body weight set point is lost, transitioning the body into a state where energy intake is favoured disproportionately to energy expenditure. But how does this happen? Here's where the brain comes in. Loss of the body weight set point is associated with abnormal functioning of a special group of neurons or nerve cells in a part of the brain called the arcuate nucleus of the hypothalamus, or the ARC for short. These ARC neurons have control over appetite and can be functionally altered by hormones that travel in the blood, such as insulin. Insulin is released from the pancreas after a meal and is probably best known for lowering blood sugar. But insulin also signals to these ARC neurons in the brain and tells them that we can stop feeling hungry. But what has changed in obesity then? Well, one of the hallmark features of obesity is chronically elevated levels of insulin in the blood. This leads to those ARC neurons becoming insulin resistant, such that they're no longer receptive to the effects of insulin. What this means is that the body thinks it's hungry all of the time. And so the question then becomes, how do we restore insulin sensitivity to ARC neurons and reinstate the signal to reduce appetite after a meal? Melbourne scientists have been exploring the possibility of using drugs to do this. In a study published last year, 2 drugs were delivered into the brains of obese mice via an injection up the nose. Remarkably, these mice experienced a massive reduction in the amount of food they consumed on a daily basis. They also saw huge decreases in whole body fat and overall body weight. Now, I know what you're thinking, and no, these drugs have not yet been tried in humans, but safety testing in human volunteers has been completed, which is a good indication that clinical trials may be on the way in the future. The potential for drugs like these is enormous. See, by recalibrating those mechanisms that control energy balance, we are effectively making those necessary adjustments in diet and exercise easier to achieve. All of this must begin, though, with a recognition of obesity for what it really is. A complex disease that we do not yet fully understand, but one that needs to be fully understood for the sake of our economy, our healthcare, and most importantly, for those directly affected by it. Thank you.